This is a lesson for Thursday, December 3rd. We're taking a look at some different kind of factoring. We're going to introduce a new special formula. Here is your new formula, a to the third plus b to the third. And what we see is that we have, instead of like a squared minus b squared, where we see perfect squares, the conjugate rule that we did. What happens if they are perfect cubes? The exponent's perfect cube, the number's perfect cube. It fits this formula. Now here's just a reminder of all your perfect cubes. So what I see as I go through is I have x to the third plus 125. Let's just start by trying to factor using this formula first, then we'll solve in a moment. X to the third plus 125. How does this fit? Does this fit? Yeah, these are both perfect cubes. It fits the a to the third. So if a to the third is like x to the third, then a is just x. It's the cubed root. If 125 is like b to the third in the formula, the cubed root, I would take the cubed root of 125. Cubed root of 125 is 5. So a is like x, b is like 5. And we're just going to plug it into this formula. Here's the formula. A is x, b is 5. So a squared is x squared. A times b is 5x. B squared, or 5 squared, is 25. There's my factors. We're going to use this to solve. So what I have is x to the third minus 64 equals 0. That means a is like x, and the cubed root of 64, don't tell me it's 8, it's the cubed root of 64 is 4. Now specifically it's negative 64, so the b value is actually a negative 4. Watch your signs here. So cubed root of negative 64 is negative 4. Wait a second, you can't take the root of a negative. Yes, you can, as long as it's odd. So it's negative 4. This is an odd root, so we're fine with negatives. So I know a and b, so let's plug it in. A plus b, x plus negative 4, it's x minus 4. So the sign stays with the 4. And then I have a squared, x squared, minus a times b. Well, there's a negative with the b, so there's actually two negatives here. A negative 4 and the negative that's in the formula, so that turns it into plus 4x. And then negative 4 squared, you know anytime you square a negative, comes out as a positive 16. Okay? Watch your signs here. This must always be positive. Anytime you square a negative or a positive, it comes out positive. Another trick to help you with this is if the problem has a minus sign, the first parentheses will have the minus sign. And these two signs must always be different. One negative and one positive. That's actually why there's no middle terms here. There's no x squared or x term, anything in between these. Because one negative and one positive in here means that if you multiply this out, it would all cancel. Okay? So watch your signs. These must be alternating signs, and this must always be positive. Alright, so we're going to solve these. X minus 4. I don't have to solve by square roots. That's a regular algebra 1 equation. X equals 4. Add 4 to both sides. But then I get this guy. Wow, this does not factor. So I need to use either quadratic formula or completing the square to solve this guy. I'm going to use quadratic formula first. A is 1, B is 4, C is 16. I plug it in using quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. We should know this by now. I simplify inside. It gives me negative 48. Pop your eye out, and the square root of 48 breaks down. That's 16 times 3. Square root of 16 is 4, so it's 4 square root of 3 with an I in front of it. This is the final answer. Now actually, this can be, I'm okay with this as a final answer, but this can be simplified because both of these numbers can be divided by 2. So I could actually do 4 divided by 2 is 2, and this 4 also gets divided by 2 and make it a reduced answer. But I'm also okay with you leaving it like this for now. One thing that's interesting with these is that these actually always work out the same way. Notice that both parts of the numerator have 4 in the answer, 4 and 4. And it's always I square root of 3. So this always works out to negative b plus or minus bi square root of 3. So if I were to solve one of these, and let's say I had, in this parentheses here, 49, then this is 7. That's what I would get from the formula. Then this is going to be negative 7 plus or minus 7i square root of 3 over 2. And it just always works out that way. Okay? Because this comes from a formula itself to begin with. You can also solve these using completing the square. And I have that down there if that's your preferred method. You can look that over. It's just the same thing we did earlier this year. All right, if you have questions, go back to the live session. Otherwise, start your homework.